let's start our topic 311 part 2 notes. So we're going to focus on secant, cosecant, and cotangent, but this time with our transformations. So just like we have for the other previous trig functions, we're going to focus in on how to graph one or two periods of these things. So first thing that we want to make sure you pay attention to is the parent function of cotangent. So parent function of cotangent would be located on the right side. There are two asymptotes, vertical asymptotes, between 0 and pi, and at pi over 4 we are still at 1, at pi over 2 we are at 0, okay, and then at 3 pi over 4 we are at -1. So those are some of the points that we're going to use when we want to graph cotangent. Okay, so what's going to happen here is, let's take a look at example number 1. So my a value is 1/2 and my b value is 4. So what that tells me is my period length, because this is cotangent, is pi over b. So pi over b means that my period length is pi over 4. So what originally took pi to complete one period is now going to be pi over 4. That means that there's a horizontal dilation by a factor of 1/4. Okay, and there's also a vertical dilation by a factor of 1/4 also. I'm sorry, not 1/4, 1/2. Okay, so our vertical asymptotes are at 0 and at pi. So when I divide by 4, my vertical asymptotes are now at 0 and pi over 4. My period length takes pi over 4 to complete. So when I quarter this up, I get pi over 16. Okay, so this is 0 pi over 16, and when I multiply by 4, this would be 4 pi over 16. So 1 pi over 16, 2 pi over 16, 3 pi over 16, and 4 pi over 16. I'm going to draw my vertical axis. Okay, there is no vertical shifts up or down, just the vertical dilation. Okay, so I'm gonna go by halves. So there's -1, there's +1. Okay, and then we're going by 16ths. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And that should be enough because 0 to pi over 4 is already where I'm going to need to be. So from 0 to from 0 and pi over 4, and then another pi over 4. So I could have actually spread it out a little more if I wanted to. But in any case, my values are normally at +1, this is cotangent, 1, 0, and -1. And because my a value is 1/2, I'm going to multiply it by 1/2. So what happens is this becomes 1/2, this is still 0, and then I am at -1/2. So at 1 pi over 16, I'm at 1/2, 2 pi over 16, I'm at 0, 3 pi over 16, I'm there at -1/2. So there is one period length of my cotangent, and then it can cycle itself all over again. There's my second period, and I am done. Okay, taking a look at example number 2, keep in mind the 2 in the front, that's just a vertical shift. I'm going to factor out the 2. So when I factor out a 2, dividing by 2 is the same thing as multiplying by 1/2, and then there's the vertical shift at the end. So b value is 2, c value is pi over 2, and d value is 2 as well. Okay, my period length is going to be pi over b. Now again, my reciprocal value of b is my dilation. So what that means is my vertical dilation is by a factor of 1. My horizontal dilation is by a factor of 1/2. I'm going to go left pi over 2, and I'm also going to go down 2 units as well. Okay, so my period length is pi over 2. And so what's going to happen is I have 0, 2 quantity x plus pi over 2, and I have pi. So divide by 2, and this is pi over 2, and then I minus the pi over 2, so that would be negative pi over 2, and then if I minus the pi over 2 again, that would put me at 0. Okay, and so if my period length is pi over 2, I just need to go from negative pi over 2 to positive pi over 2, and that's how I can complete 2 full periods of this graph. I multiply it by a quarter to get pi over 8. So when I do pi over 8, this is negative 4 pi over 8, and this is 0 pi over 8. So negative 3, negative 2, and negative 1 pi over 8. Okay, so like I said, I just need to go between negative pi over 2 to positive pi over 2. So I can actually be a little more generous with my intervals this time, because I only have to go to negative pi over 2. So 1, 2, 3, 4. So there's negative pi over 2. 1, 2, 3, 4. There's pi over 2 as well. The a value is 1, so what was once at 1, 0, and negative 1, because the a value is 1 doesn't change, but because the d value is 2, I'm going to add 2 to all of these things. 2. So this puts me at 3, 2, and 1. So now that I'm going to graph, negative 4 pi over 8 is my vertical asymptote. At 0, I have a vertical asymptote. And pi over 2, I have a vertical asymptote. Okay, at negative 3 pi over 8, I'm going to 1, 2, 3, 4. At 3 pi over 8, I'm going to be at 3. At negative 2 pi over 8, I'm going to be at 2. At negative 1 pi over 8, I'm going to be at 1. And then I'm going to repeat 3, 2, 1. And so there's my graphs of cotangent. Okay, so those are 2 problems for us to practice cotangent. Turning the page, we're going to take a look at cosecant and secant, the reciprocal functions of sine and cosine. Okay, so for cosecant, again, the main idea here is you have to figure out where sine is, and wherever sine is, the zeros of sine are your vertical asymptotes, and the max and min values of sine are going to be like your vertices of a parabola, almost is the way to think about it. Okay, and the same concept for secant, you're going to graph cosine, so it starts at a maximum, drops to a minimum, and back to a maximum over 2 pi. And again, from there, as your values of cosine, all the x-intercepts, all the zeros of cosine become vertical asymptotes because the reciprocal of the 0 would become undefined. And then your max and min values give you your shapes for your U-shaped graphs to go up and down. Okay, so that's what we need to consider there. Period length of secant and cosecant is also 2 pi. You need one of the upwards and one of the downward ones to complete one full cycle. Okay, domain are all real numbers except your vertical asymptotes. And your range is from 0, negative infinity to negative 1. Actually, there should be a bracket there, here, and here as well. Okay, so that's what we need to consider there. So now, what we're going to do is talk about graphing it. So it says find the reciprocal function and graph that function. So use the steps from graphing sine and cosine like we've been doing, using the equation with the ABCD. Okay, this graph will be a guide for you to create the cosecant and secant because that'll give you your vertical asymptotes and your points. Sketch the vertical asymptotes which go through midway points of your sine and cosine graphs. These midway points go through the horizontal line y equals c. To sketch the graph, start at cosine or sine's maximum points, draw the U-shaped curve between the asymptotes, and then head it towards your asymptotes as well. Repeat this for cosine or sine's minimum points too, because that'll be your upside down U shape. Okay, so turning the page, we're going to take a look at example number 3. So looking at example number 3, we're graphing cosecant. So 3/2 cosecant of the quantity x minus pi over 2. So cosecant is a reciprocal function of sine. So I'm going to consider the graph of 3/2 sine of x minus pi over 2. So what I know here is my amplitude for sine would be 3 over 2, 1.5. And so I'm going to think about sine. Sine has a period of 2 pi. And so my b value is 1, so the period's still going to be 2 pi. And I have 0 less than or equal to sine, not sine, just my horizontal, x minus pi over 2 less than or equal to 2 pi, because that's one period length of sine. I'm going to add the pi over 2 to the other side, so pi over 2 less than or equal to x less than or equal to 2 plus pi over 2, so that leaves me with 5 pi over 2. My period length is 2 pi, so 2 pi, and I cut it into quarters, becomes pi over 2. So what's going to happen here is I have pi over 2, 3 pi over 2, 4 pi over 2, and then 5 pi over 2. 2 pi over 2, 3 pi over 2. There we go. 5 pi over 2. There's my 5. So if I'm going to graph, I'm going to draw. My amplitude is 1.5, so I have to make sure I get to 1.5. Okay, and negative 1.5, so half, 1, half, 2, half, 1, half, 2. And I'm going to be going by pi over 2's. So 1 pi over 2, 2 pi over 2, 3, 4, 5, 6, 7, 8. Oop. 1, 2, 3, 4, 5, 6, 7, 8. Okay, now I'm going to draw in sine. So sine is going to be from pi over 2 to 5 pi over 2. And so at pi over 2, I'm going to be at my 0. And then I will go up to 1.5, down to negative 1.5, and then at 5 pi over 2 I'm going to complete. Okay, and then I'm going to repeat it if I like, up, down, and then back. And that would be 2 right there for sine. Okay, if I wanted to do more, I could. So I could go down to 1.5 and back up to 1.5 and so forth. Okay, so there's my graph. And so what's going to happen now is I'm going to take my zeros and for all of my zeros, I am going to draw my vertical asymptotes in. And at my max value, if I'm above the x-axis, I'm going up. And then at my minimum value, I'm going to go down. And at my max value, I'm going to go up. And at my minimum value, I'm going to go down. And then maximum, I go up. And minimum value, I go back down again. Okay, and so that would be how I would graph my function here. Next step, for example, number 4. Okay, same thought. I am going to be dealing with secant. So secant is the reciprocal function of cosine. So my A value is 2. My period length is going to be 2 pi over 1/2, which is equal to 4 pi. Okay, so 0 less than or equal to 1/2 x less than or equal to 2 pi because it's cosine. So when I multiply by 2, I know that my graph is going to go 0 to 4 pi because the horizontal dilation. So that means I can go right to 4 pi and I can go left to negative 4 pi. Okay, and then I will go as high as 2 and as low as negative 2. One, two, three, 4, 5, 6. One, 2, 3, 4, 5. So there's my pi over 2's. Okay, 4 pi times 1/4 is pi. So 0, 1, 2, 3, and 4. Okay, I'm going to start at my maximum because it's cosine. 0, minimum, 0, maximum. Okay. Down, back, up, and then back. Okay. All the zeros are asymptotes, vertical asymptotes. Maximums are up, minimums are down. Like that. Okay, so we're going to pause here. We're going to have you try examples 5 and 6. Be careful that there are vertical shifts, which means that's going to shift your sine and cosine graphs up and down as well. Okay, so pause here. Try examples 5 and 6. Okay, for example number 5, cosecant is the reciprocal function of sine. So we're going to treat this as sine of x plus pi over 3 minus 2. So first thing is we're going to deal with our sine values. So I got x plus pi over 3 less than or equal to 2 pi. When I subtract the pi over 3 to the other side, so 2 pi is the same thing as 6 pi over 3 minus pi over 3. So this is going to be 5 pi over 3. I'm going to quarter this up. My period length is 2 pi over 1 because my b value is 1. And so when I quarter it up, that leaves me with pi over 2. So between the 2 and the 3, I'm looking at denominators of 6. So times 2, this is negative 2 pi over 6. Times 2, this is 10 pi over 6. And then times 3, we're looking at 3 pi over 6. So when I add 3, 1 pi over 6. Add another 3, we got 4 pi over 6. Add another 3, we got 7 pi over 6. Okay, so I am between... I need to account for the down 2 units as well. So what I'm going to do first is I'm going to graph sine, and I'm going to account for the down 2 afterwards. So denominators of 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, like that. Okay, sine So we're gonna go mid, max, mid, minimum, back to mid. Okay, so negative 2 pi over 6, 1, 2, 3, 1, 2, 3. So starting at 0, we go to the max at 1 pi over 6, back to the mid at 4, minimum at 7, maximum at 10, 8, 9, 10, or mid, 1, 2, 3, 1, 2, 3, 1, 2, 3 to the left, 1, 2, 3, 1, 2, 3, there. Okay, so this is the graph of sine. Okay, I did not account for the minus 2 yet. First, I'm going to put in my asymptotes. 1 there, asymptote. Okay, now that I have my asymptotes, now I'm going to shift. So, because of the minus 2, my maximum is down 2 units. Okay, so it's going to be down there. My minimum is going to also shift down 2 units. So when it shifts down 2 units, 1, 2, I'm at negative 3, and then I am down here. Okay, this one is going to be up because it originally was above. Down 2 units, opening up. Down 2 units, opening down. Down 2 units, and opening up. Okay, so that's how I would account for the minus 2 at the end as well. Okay, number 6. This is negative cosine that I'm going to consider. Okay, so cosine is between 0 and 2 pi. So negative 3 pi over 4. And 2 pi is the same thing as 8 pi over 4. So that would be 5 pi over 4. My period length is 2 pi because my b value is 1. So when I quarter it, it's 2 pi over 4 already. Okay, so that's enough information. Okay, now I do need to make sure that I start my cosine by handling the reflection over the x-axis. So instead of starting at a maximum, I am going to be starting at a minimum. Okay, so minimum, mid, maximum, mid, minimum. Okay, so I'll set it up. I'll go by fourths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12. Okay. So starting at 3 pi over 4, I'm going to start at a minimum. So negative 3 pi over 4 puts me at negative 1. Negative 1 pi puts me at the mid. Positive 1 pi puts me at a max. 3 pi puts me at a mid. 5 pi puts me at a minimum. 2 more to the right. 2 more to the right. 2 more to the right. And then as I work my way left, 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 left. So here is my cosine, negative cosine of x plus 3 pi over 4. Okay, vertical asymptotes. We'll draw in. Okay, and then the last step is because of the plus 2, I'm going to go up 2 units. So my maximum goes from 1 to 3, and it opens up. My minimum from negative 1 goes up to positive 1, but it opens down since it started below. Okay, and then up to 3, up to 1, up to 3, and so forth. Okay, and so that would be how we would graph this one. Okay, last page, evaluate. So evaluating the trig function using the reciprocal concept. So what that means is this. If I have secant, secant of pi over 4 is the same thing as 1 of cosine over pi over 4. So consider cosine of pi over 4. So cosine of pi over 4. Okay, so cosine of pi over 4 is root 2 over 2. So secant of pi over 4 is the reciprocal, so 2 over root 2. And if you rationalize that denominator, we're looking at 2 root 2 over 2. So we're just down to square root of 2. Okay. For b, secant is the reciprocal of cosine. So cosine of 5 pi over 6 is going to be negative root 3 over 2. So therefore this is negative 2 over root 3. Rationalizing my denominator, I am at negative 2 root 3 over 3. Secant of pi is the reciprocal of cosine of pi. So cosine of pi of negative 1, that means secant of pi is also going to be negative 1. Cosecant is the reciprocal of sine, so I'm looking at sine of 5 pi over 4. So this is negative root 2 over 2. So negative 2 over root 2, when we rationalize, I'm looking at negative square root of 2. Okay. So now we have a negative angle, so we're looking at sine of negative pi over 3. Okay, keep in mind, sine of negative pi over 3 opens this way. So that means that if I want the positive angle, that's the same thing as sine of 5 pi over 3. So sine of pi over 3 is negative root 3 over 2. So negative 2 over root 3, so which is negative 2 root 3 over 3. Okay, last one is cosecant of pi. So sine of pi is going to be 0. So we're looking at 1 over 0, which is undefined. And that's why we have vertical asymptotes. Okay, last problem, find the following. I want the range and I want the period. So I'm thinking about secant is the same thing with sine here. Okay, so my period length is going to be 2 pi over b. But since b is 1, my period length is going to be 2 pi. Okay, my range normally starts in between negative 1 and 1. However, I do have a vertical dilation of 2. So my vertical dilation would extend it from negative 2 and 2. But I also need to go down 1. So when I go down 1 unit, that would put me at negative 3, and this would put me at 1 when I shift down. So this would be my final range for the problem.